17, we are given a figure. Okay, so we have this figure over here, and in part, and we are also told that the length of the major arc is 24 meters. So we want to find the length of the, we want to find the reflex angle AOB, which is actually this angle here. So since we have the formula already, that S equals to R theta, where S represents the arc length, so 24 is equals to the radius times the theta. So the reflex angle will actually be 4 radians. Okay, so that will be the answer. I want to find out that, okay, because the question asks for radians, okay, usually, right, we don't need to write the word radians. The word radians itself is not a unit actually, right? I don't know what word to use to represent it. Okay, so we don't need to actually write the word radians, right? So whenever that number that represents, there is a value for the angle itself, as long as it doesn't have the degree symbol itself, right? Okay, we will take it that it is going to be radians. So you need to be able to recognize it. Alright? Any questions? Okay, so we leave it this way. You can, okay, but I will just want to tell you that in the exam, sometimes they will give you an answer blank, right? Alright? They will not put the word radians over here. And you don't put it. Okay, you don't go and put extra one. Right? So that's the thing, that's the standard. Okay? Because radians, the word itself is not the symbol, it's not a unit. Okay? Then part 2. We want to find the area of the major segment APB. So we're looking at the segment itself. Okay, that will actually refer to this entire thing. Okay, is it A? Sorry, I read it wrongly. Part 2 is trying to find AP. Part 3 is finding area of major segment. Right? Yes. Okay, so part 2, to find out what is the length of AB, since we already got the angle, reflex angle AOB, then the angle AOB itself will be 360 degrees minus away the reflex angle. But of course 360 degrees is in degrees. We cannot use degrees with radians. So we use 2 pi minus away 4 for the angle AOB. Okay, so we are actually referring to this triangle here. 6, 6, this is 2 pi minus 4. Okay, and we want to find the length of AB. Alright, so we can use our cosine rule. That will tell us that AB squared equals to 6 squared minus 266 cosine 2 pi minus 4. Right? Make sure your calculator is in radian mode. And then the length of AB will be 10.9 meters in 3SF. Let me double check the accuracy. 911. Okay, then in part 3, we want to find area of the major segment. So area of major segment is the area of the major sector plus the area of triangle. And the triangle name in this case is AOB. So the area of the major sector will be half R squared theta. That is the formula for area of sectors in radians. Okay, so radius being 6 and theta is the reflex angle AOB. So we got half times 6 squared times 4. And the area of the triangle, we will use half AB sine C. So AB will be 6 and 6 and sine of 2 pi minus 4. Once again, again make sure the calculator is in radian mode. And then we get 85.6 meters square to 3 SF. Okay, any questions? Does anyone have any issues pressing radian mode in your calculator? All can press, huh? Okay, great. So when it comes to trigo, whenever using calculator for trigo, make sure that you're in the correct mode. Okay, because I've seen many times, okay, that students take WA, then after that the whole paper is on trigo, then the whole paper is in degrees, right? That person did it in radian, okay, then everything is wrong. So please don't sacrifice yourself like that. Yes. You don't know how to use the radian, and so you don't know how to change calculator to radian. Just press numbers, it's the same. Press exactly what you see. What do you mean you don't know how? You change radian mode already, right? You change, as long as you change already, you just press exactly whatever that you have here. You cannot change to degree. Please don't waste the time to go and change to degree. Okay, can you do that now? Alright, try pressing this entire thing when in radian mode and then get 85.6. Okay, I don't want you to end up having to change your angles, keep on changing to degree. Alright, then after that you may end up losing accuracy when you do changing. Okay, and then you're also losing time when you change. You get it, Joseph? Have or not? Don't have? Which one got the half 6 square? So 6 square. Yeah, correct. Yeah, so yeah, set up. Okay, great. Alright, question 23. Okay, we are also given a figure. It's a square this time round. And there is this sector here. K, C, H, D, A, B, 10 cm, 12.5. Okay. First question, we want to find, HK is in our circle center A, where AK is 1.5, find angle HAK. Okay, so we want to find the angle of HAK. Alright, so any ideas on how to do it? We know that this is a square, right? So we can have right angle triangles. Okay, so what we can do is to first find out what is this angle. Okay, so if I can find out what is this angle, then I can also find out this angle here. Alright, they may not actually, they are going to be the same value, or actually, let me explain later on. Then after that, I can take 90 degrees minus away these two angles, and I will be able to get what I want. Okay, so how do I even get the angle of HAB? If I focus on the right angle triangle here, this is 10 cm and this here is 12.5 cm. So what can we do actually? And so what can we do? To find angle DAH, using looking at the right angle triangle. Sine rule, it's a right angle triangle. Let's look at Picasso. You want me to draw another triangle here? Picasso tells us to choose which one? Cosine, yep. So we do cosine. So cosine of angle BAH equals to adjacent over hypotenuse. we want to keep this in radians. Okay, so make sure when you do your cosine inverse, you are also in your radian mode. So cosine inverse 10 divided by 12.5, you will get 0.64350. Okay. Then for angle KAD, actually it is also the same right angle triangle because triangle KAD will have this side being 10 cm and then after that the hypotenuse here is 12.5 cm. Okay, so looking at this one, adjacent over hypotenuse, so angle KAD is the same. So therefore the angle of KAH will be taking 90 degrees. So we need to be familiar with certain special angles when they are in radians. 90 degrees will be pi over 2. So angle HAK, pi over 2 minus away 0.64350 twice. Okay, and we will get answer 0.284. That will be in radians. Next, part 2, the area of the shaded region HCK. Alright, what would you consider doing there? Katja, what do you think? You want to find the area of the shaded region. She's here. Area of the sector, KAH, so find the area. Okay? Let's find that first. Area of sector, KAH. And how do we do that? Okay, so half r square theta. Okay, theta we will take 0.28379. Right, and we get a value which is 22.171. Then what else do we need to find? Okay, area of triangle HAB. That is actually equals to the other triangle as well, since we recognize that they are congruent, which is what we're going to do after this, congruency and similarity. Okay, we take half times 10 times 12.5. Half times 10 times. Sorry, we can't do half times base times height. We got to do half AB sine C. Okay, so you find that value here, right? Therefore, the area of the shaded region will be considering the area of the square, which is 10 times 10, minus away 22.171, minus away, I leave you to do the calculation, 2 times of that stuff. Okay, final answer will be 2.86 cm squared, when left to 3 SF. area of the shaded region. In finding the part I, is it? Who asked for question 25? Is the issue on part I or is it on part 2 in finding the area of the shaded region? Why always like that one? I'm very sure I saw hands raising up. What's the issue for question 25? Yes, the whole thing. So part I don't know how to do that, so part 2 cannot, right? Okay. So in part I, right, the important information that we need to make use of is the fact that the arc length PQ to QR has this ratio 4:3. Okay. Take note that POR is a quadrant. A quadrant is how many degrees? How many? Yes. Quadrant of a circle is how many degrees here? Under POR. 90 degrees, right? Okay. And then down here is 4:3 ratio, right? So even if the arc length may be of a different, maybe of certain value, right? But the ratio being 4:3, it will be 4:3 ratio for the angles as well. Okay. So essentially, yes. 2.83. Okay, whatever accuracy that y'all take. Alright, I'll leave it to y'all to do that calculation. I will not change. Okay, so for this one, right, the theta itself, the entire quadrant is 7 units long. Since we're trying to find the angle for theta, which is 3 units, occupying 3 units for this entire 90 degrees, 3/7 times 90 degrees, but we want it in radians. So 90 degrees is pi/2. So we get 3pi/14. Okay, so that is how we do part I. Alright, we need to understand that the ratio of the arc lengths will actually be proportional to the ratio of the angles as well. Alright. Then after that, to find the area of the shaded region, we will need to find the area of the minor sector or QOR. So that will be area of triangle POQ plus the area of sector QOR. So we have half times 15 times 15. Okay, because OQ is actually the radius U times sine of angle POQ, which is pi/2 minus 3pi/14 plus half r squared theta. Okay, and we should get a value of 164 when rounded to 3 SF. Okay. Any questions? Yep. 77.5. This one? KAD. 37.5. Yeah, I know. This one, because this one you took an accurate answer, right? What is in, what do you mean? How do you get 37.5?
It is exact.
When you use 0.64350. If you use the previous answer, yeah, you will get 37.5. Yeah. So that's why I am never concerned about whether you get what kind of answer over here. As long as it's around similar, okay, for you, you should know that it will be accepted. Okay. So my concern is always the method that we are going through. Okay. Final answer, because of all this accuracy issue, depending on your choice of accuracy, if some of you take an accurate answer over here, then following it will actually be different. So I cannot address all the different cases, and it is a waste of time for me to do that. Okay, it will be more efficient if I just cover the concept behind it. Okay. And I also want to point out that your textbook doesn't follow and comply with exam standards. Alright, so you need to know what are the exam standards in terms of the accuracy required. Okay. So that's all. Okay, can you please pass down your homework to the front? Where we are going to look at congruence and similarity. We have already learned what is congruence and similarity back in Set 2. Okay, do you remember what is congruence and similarity? Nobody answer me. What is congruence? What does congruence mean? Yep. Two shapes. Same. Size. And angles. Great. Okay. So for congruent figures have the same shape and same size. Okay. And because they are of the same size, it results in the angles and the sides being equal in length, okay, as well as equal in size for angles. Okay, but more importantly, it is the corresponding ones that are actually equal. What about similarity? Okay. Okay, so for similarity, as per what Joseph was saying just now, okay, so similarity has same shape, but different size. Okay, but it cannot be entirely different sizes, alright? It must actually, in fact, be proportional to each other. Okay, so proportional in size is an important concept regarding similarity, right? Then, when we have proportional in size, we observed when we were in Sec 2 that the angles itself will actually be equal. Then for the sides, okay, they must be equal in the sense of the ratio, alright? So ratio of sides, of corresponding sides. Okay, so that's what we covered when we were in Sec 2 regarding congruence and similarity. So then what is this chapter going to be about? This chapter is going to be on the different proofs that we are going to use to justify that two things are going to be congruent or two things are going to be similar. Okay, why is this blue? And now it's an entire blue screen. Alright. Okay, so for your convenience, I already consolidated it into this piece of worksheet over here. Okay, regarding the different tests that we will use and the way that we are going to write the test. Okay, the format of writing. So for congruence, okay, as mentioned, same shape, same size. So we have this SSS test. SSS represents side, side, side. Okay, so three sides. Right? If we can prove that the three sides, three corresponding sides, in fact, are actually equal, then surely it will have to be congruent. Right? So one of the proof, okay, the way that we prove is that we need to show AB is equals to PQ, and what is that value? BC equals to QR, find out what is the value, and AC equals to PR, and determine what is that value. Okay, so it's dependent on the question itself. Right? So after we have done that, then we have to have a concluding statement that triangle ABC is congruent to PQR. When we write this concluding statement, right, we need to ensure that the vertices actually match. Okay? So in this case, A matches up with P, so it must be a P over here. Then B actually matches up with Q, so it must continue with a Q, and C matches up with R, so therefore we can only write ABC is congruent to PQR. Of course, I can also say that BAC, alternatively, if I want to, I can say triangle BAC is congruent to triangle QPR. That is also fine as well. So in this statement, what we got to ensure is that the vertices match. Okay, the corresponding vertices match up. It doesn't matter what is the order that you first write it, as long as for the second one it follows in the same corresponding order. Okay, so we must also do the same when we write down the length also. So AB equals to PQ. I don't say AB equals to QP. Then another test that we have is the which is what I think you all want to write. Okay, so no ASS test and no SSA test. Okay, so the short form needs to only be SAS. The reason for that is because the angle that we are going to take must be the included angle of the two sides in our group. Okay, so that's why it must be SAS test. So in the SAS test, they are always flying at this time, right? The airplanes. And my lesson is always at this time if you're. Okay, I think it's done. Alright, so SAS test. Okay, so we chose one side AB. Okay, the matching corresponding side is PQ. So we use that one statement. And if I were to choose the other one, BC and QR, okay, I got to ensure that the angle that we're going to be looking at is the included angle, which is ABC with PQR. Right? Okay, all the blanks are actually dependent on the question itself. Then we say that likewise ABC is congruent to PQR. And just now I forgot to mention and emphasize on the need to write down what is the test that you are using. Okay, you need to write down the test that you are using to prove congruency or later on similarity. Then after that, the third one that we have is the AAS. In this case, I can write it as ASA or SAA. Okay, so two angles and one side. So the angles itself can be any two angles in the triangle, and the side can also be any side. Okay, then we will have triangle ABC is congruent to triangle PQR and the test. Okay, the reason why all these tests actually work is because, right, okay, you can go the extra mile, okay, which is a bit of a redundancy, right, to actually use sine rule, cosine rule, go and prove, okay, find out all the remaining sides. So with this given information, the remaining steps are to actually find using sine rule or cosine rule the sides of the remaining, the length of the remaining sides, okay. Then after that, you can justify that they will be of equal sizes. Right, but of course, we don't need to go through that procedure because just by using this test, it will be sufficient already. Right? We don't always have to use SSS test. And the last one, okay, RHS, okay, which very strangely, many people think about using right hand side, okay, although yeah, we use that as a short form for right hand side. But RHS stands for having a right angle, a hypotenuse, and a second side. I want to be clear that okay, it is not always when you have a right angle triangle, then we must use RHS test. Okay, so sometimes okay, right angle triangle can also use AAS or SAS test. So don't always go through that insistence that right angle triangle must be RHS. Right? So RHS, right angle, hypotenuse, and side. In order to prove that they are actually congruent. Okay, so right angle 90 degrees, then the two other sides. Okay, there's no conditions for the other two sides. As long as one of it is a hypotenuse. Okay, then this one, oh sorry, I realized there's a typo here. Okay, this one is RHS. Yep.
Shouldn't the first one be USA?
Shouldn't the first one ASA, which one? This one. AS also can. Now, I don't need to be ASA. SAA. This one it doesn't matter. Okay, the SAS one must be A in between because the A is an included angle for the two sides. Right? Okay, let's take a look at practice round 1. Yeah. Congruency for circles. Why will you need congruency for circles? Two circles are congruent so long as the radius are equal. You don't need to prove that the circumference is equal, right? Okay, let's look at practice round 1. I want to look at question 2. And we are given a kite. Okay, we want to identify the two congruent triangles in the kite and prove that they are actually congruent. Right? Something that I find it very useful for myself is to usually I draw two triangles side by side. They are actually of the same orientation. So for WXY, I have it in this manner. Then after that, the other one I draw it in the same orientation as WXY. Okay, don't have to be exactly the same. It's just a law for reference. Okay, then after that, I know that these two sides corresponding. These two sides are corresponding. Okay, then after I put in the vertices, right? So I know that Z is in between the single line and the double line. So Z must be here. Okay. W is where it is between the single line and no line, so it got to be here, and Y. Okay, the reason why I do this is so that when later on I write down my proof, I will not be confused in terms of the vertices matching. Right? So I find this very useful in my proof. So to go about proving these two triangles, we know that WX is equals to WZ. I do not write ZW, okay, because this is given information. So we put bracket given. So all the properties that you know, okay, all the short form for angles, angle properties and all that needs to be out in your congruency and similarity test. Okay, you need to write down the reasons very carefully for each statement. Then the next one is XY is equals to ZY, which is also given. Okay, the question did not give any angles at all, so we cannot be using any of the tests that requires angles. Okay, so what we will do is, in fact, notice that WY is shared in common between the two triangles, so we write that as WY is common. So now we got three corresponding sides that are actually equal, and we conclude that triangle WXY is congruent to triangle WZY. And this is due to SSS test. Okay? I want to address that also. Alright, so when it comes to the word congruent, I prefer it if you use the word congruent rather than for you to use the three lines. Okay? Reason is because I scared you miss out one line. Okay? I rather you just write the full word congruent. In any way, you wouldn't misspell the word congruent because question will ask you prove that they are congruent. The word is there for you to copy. I don't want to answer that. Two words good lah. Okay. Next, practice now 2. Okay, question 1. We are given these two triangles. Okay, triangle. refer to your textbook for a more accurate diagram. Okay, and the question says that angle PQR is equals to angle SPT. PQR is here, SPT. Okay, we want to prove that the following two triangles are congruent. So, like what I did earlier, okay, I will do one triangle first. So PQR, and then I do another one that is of the same orientation. Okay, then I fit in the information. Okay, because they got to be congruent, right? So the corresponding stuff got to be equal, got to match. Then after I put in the vertices, so it is angle P that has this angle here. Then after that, T is in between one single line and then nothing, so it will have to be here. And then S has to be here. Okay, so when I allocate my vertices, I will know and make no mistakes in terms of my proving already. Okay. So now let's proceed with the proof. PQ is equals to SP because that is given. Okay, and we see the angle PQR is equals to angle SPT. Likewise, that is also given. And then QR equals to PT, which is also given. Okay, so we are using side angle side. We conclude that triangle PQR is equals to triangle SPT. Sorry, is congruent to then this would be the SCS test. In question 2, we want to determine whether the two triangles here are congruent or not. Okay, so what I will do is to keep the orientation of ABC. I manipulate around my X, Y, Z. Okay, then I need to put in the information, right? So we got a 12 cm here. Okay. And then 36 degrees. We want the AB to actually be 7 cm and then down here should be 7 cm. But we notice that with the triangle that is given, it is actually 10 cm here. Okay? Because in this question it asks to determine whether is it congruent. Whereas the previous two questions, they ask you to prove that they are congruent. Right? I don't know whether you notice the difference in the questioning. So practice now 1 and 2. Asked to prove that the triangles are congruent. Whereas in this question, they asked to determine whether they are congruent. So the difference in the two questions, the way that it asks, when they ask you to prove that they are congruent, it means that surely they are congruent already. Because if they are not congruent, then there's nothing to prove. Correct? Okay. Whereas for this question 2, they ask you to determine. So there is that chance that they are actually not congruent. Okay. So in this case, when we draw a triangle, we may want it to be 7 cm here, but when I check with this, there is a 7 cm, but the 7 cm doesn't belong here. The 7 cm actually belongs here. Okay, so now I put in the x, y, z. Right? We see very clearly now that they are not congruent. But of course, I cannot just use two images and say that, oh, they are not congruent. Right? I need to write it down in words. Okay? To say that, I erase this out. So I'll say angle ABC equals to 36 degrees is the included angle of sides AB and BC. Okay, write down the length. However, angle XYZ, which is also 36 degrees, is not the included angle of sides XY, XY is XZ and YZ. Okay, so the emphasis is that XZ 7 cm when we want it to be XY 10 cm. We want it to be XY to be 7 cm instead. Okay. So if only the included angle was actually here, okay, then we can use our SAS test to determine that they are actually congruent to ring. Are there any questions? Okay. I want to go to practice now 3, but it is rather lengthy because there's many ways of doing it. I'll bring that for discussion the next lesson tomorrow. Okay, so I'll just stop here for today regarding the SAS and SSS test. Piece of worksheet that I gave you properly so that you have easier reference.